Let's dive right in. This is a quick workflow for importing data directly into geometry nodes. We'll cover mesh and curve setups and highlight some key differences between Blender 3.3 and newer versions 3.4 and onwards. As usual, there are timestamps in the description. While you can directly import data into geometry nodes, we're going to use a slight workaround that has more flexibility. I'll be working with CSV files in this tutorial, but you can also use JSON files. To begin, we need to download Simon Brogie's Blender Spreadsheet Importer add-on. This is available for free on GitHub, and I've linked it in the description. A massive thank you to George G. from Barcelona, who pointed out this resource to me, and of course to Simon Brogie for developing it. To download the add-on, navigate to the Releases page, download the zip file, and from there we're going to transition over to Blender. In Blender version 3.3 or 3.4 and onwards, we're going to come to Edit, Preferences, Add-ons, we're going to choose Install, and I'm going to navigate to wherever I downloaded the zip file. In this case, I would simply select the add-on, click Install, and as I already have it installed, you can find it simply by searching for Import Export Spreadsheet Data. Make sure the mark is checked here, and while we're here, we're also going to make sure that we have the Node Wrangler add-on installed. So the check mark should be there, and with that, we're good to go. Once the add-on is installed, we should have a new option under File, Import. If I come all the way to the bottom, you can see Spreadsheet Import.csv or JSON. I will focus on CSV for this tutorial, and we'll start with importing mesh data and then move on to curves and graphs. We'll start with mesh data since it works in a very simple way in both versions 3.3 and 3.4, and it highlights all the main concepts. For this example, I'm using an artificially generated 3D grid that I created from scratch with extra data variables. This specific example was inspired by Mohammed from the Blender.science Discord, who posted a cross-section of cement that assigned different colors to each point based on the chemical composition. The key idea here is that we can recreate our 3D information and have extra information to work with, and this would be well suited to any chemical imaging in 2D or 3D, including AFM, SEM, TEM, XRD, GWAX, Raman, etc., along with all kinds of other data formats from other analytical techniques. Really anything that is going to give you points in 3D space that have variables assigned to them. To demonstrate importing the data into Blender, I'm going to use a smaller file set of only 10,000 points. To import, I'm going to come to File, Import, Spreadsheet Import, and then I'm going to navigate to where I have my data. Once I have my file chosen, I can add however many entries I'd like. One key thing worth noting is that I have to match the field names to whatever is in the CSV file. In my particular file, that means X, Y, Z, data 1, and data 2, matching the case and the spaces. I also need to be careful to match the type of data, namely floats, integers, or booleans. This does not import string data and doesn't support that at the moment. Back in Blender, you can see I can go ahead and add these in. I will double check that my delimiter option of comma is correct, which it should be for a CSV, and then I can simply go ahead and import the spreadsheet. I'll delete the default cube, and we can see that we're left with our data, which is essentially a straight line of points. If I come to the object data properties and scroll down to attributes, you can see Blender has imported, using the add-on, all of the attribute values for every single point. So X, Y, Z, data 1, and data 2, and there are exactly 10,000 points, which you can see in the vert count at the bottom right here. From here, we'll switch to geometry nodes and create a new node tree. To move everything into position, I'll simply drag out from the input and add in a set position, which I will connect up to the other end. I'll drag from the position to create a combine XYZ. And for each individual socket, I'll drag out to create a named attribute. My attributes have already been stored, and so I can simply look and say X. We'll duplicate this with Shift-D, change this to Y. And again, duplicating, we'll change this to Z, and we'll connect the respective sockets. And now you can see that my grid data, rather than being in a straight line, has correctly arranged itself in space according to the data that was present in my CSV. I'm going to quickly switch to a larger data set, and once I have, then we're going to see some of the things that you can do just very quickly once you have your CSV data imported. On display now, we have 100,000 data points, and we could do some very simple transformations to select ones that have specific properties outlined in data 1 and data 2. For instance, I'm going to drag out and create another set position, and I'll connect this to the output. From here, I'm going to drag out a selection and say compare less than. You can see this is an integer value, and that's going to work just fine because my data 1 and data 2 are both integers. I'll drag the A socket out to create a named attribute, choose data 1, and I'll say for any value less than 4, we want to move the, let's say, y-axis over by 5. Now, because I generated this data set with all random values, this essentially looks like a complete full block, but if we were to drag this number up or down, we could select different distributions of what is present in here. And so when you have meaningful data, you'll be able to see and isolate sections depending on what you want to separate. This is just one of many possible tools that you could use. For instance, we'll go ahead and we'll actually start by creating instances on points. One thing worth noting when you're working with very large data sets is that instances can very quickly take up quite a bit of system memory. So even though they are quite efficient, you have to be careful about what you choose to instance because we could put anything here. It could be a simple cube, a plane, a very complex piece of geometry. And when you start working with larger numbers of data points, 100,000, 500,000, a million, it will slow Blender down quite substantially. So we're going to color the data points specifically based on what is present using a simple cube. I'm going to add a set material node, connect this. We'll come to the shader editor, add a new material, which we will call cube material, and we'll assign it here. You'll notice that my instances are far too large, and so I'm very simply going to drag this value down quite substantially until I can really see the individual separation between the cubes. One thing worth noting in Blender is that when you're working with large numbers of instances, it can actually be faster to simply change to the Cycles render engine, use GPU compute, and then view your system in a rendered view. Cycles manages instances a little bit more efficiently than Solid View, and for a more thorough explanation of this, I will point to some videos by Arendelle in the description. For now, what we want to do is realize all of our instances, and then we're going to manipulate using our data values what color each of them is assigned. So we'll go ahead, drag out from here, realize instances. This is going to create substantially more geometry, so it might slow everything down just a little bit. But from there, we're going to come to the shading tab, and then we'll set up some element-specific coloring, or rather, data 1 specific coloring. You can see now in our shading tab, we have our cube material. It's very important that we were working with the correct one. If not, then we would have to select it from the options. And it's also important that we did, in fact, realize the instances and then assign the cube material. As those two things have been done, in the shading tab, we're very simply going to add in a color, hue saturation value. I'm going to choose something blue to start, and we'll connect this in right here. We'll zoom in, we'll make sure that we're in the Cycles rendered view, and everything has the same color at the moment. I would like to use the data values that I imported. So I'm going to add an input attribute, and I'm going to type in the name of my attribute. I have to be case sensitive here, so data 1, there's a space in there. And I'm going to reroute this using the factor output to say map range from the maximum value of, or the minimum value of 0 to the maximum value of 10. And I'm very simply going to remap that from 0.1 to 0.9. I'll plug this result into the hue, and now you can see all of these points have a different color associated with them. And because I separated out everything that is under or over 4, we have what look like two very distinct domains. If I wanted to, I could also create black and white selection masks. So let's go ahead, drag the factor out here, do a compare. And in fact, we're not going to use compare, we'll use less than and say everything less than 5. We go ahead and show that. This is all the values that are less than 5, and I can use this black and white mask to control other aspects, such as the alpha. So I could effectively make certain cubes invisible. So if we go ahead, bring this back, and now we're actually going to come to the geometry nodes and just temporarily change our set position so it's not offset at all. You can see I'm now effectively removing some of the data using the shader nodes. And we can adjust this on the fly. So let's say we want to be a little bit more selective and say, I only want to see the points that are less than 2. There we go. Or less than, let's say, 8. So now we have a whole range of tools for working with different colors, different visualizations, and of course for separating our data in space using geometry node. There are plenty of other tools available in both geometry nodes and shader nodes for manipulating and understanding and visualizing different aspects of the data, and I will explore some of those in future videos. For now, I'd like to move on to working with curves and graph data. Before I do that, I will note that I tested the importing on a range of CSV files in Blender 3.3. In my case, the files all had 4 columns, X, Y, Z, and data 1. Most smaller datasets will be imported very quickly. Anything 10K points or fewer is practically instantaneous. However, when you get into larger numbers, say 100,000, you may see a slight pause of around 30 seconds. This does not scale linearly. 500,000 entries took my computer about 5 minutes to load, and 1,000,000 points took around 15 minutes. Once the data is loaded, some simple manipulations, such as set position, can be done quite quickly. The bottleneck is really the Python code being used to import the data. That being said, if you want to create and realize instances or do more complex manipulation geometry nodes with large numbers of points, you will likely encounter some lag. And again, it is often better in that case to switch to the cycles viewport with your GPU, assuming you have a GPU, and then to run everything in that form. From here, we can move on to graphs and curves. I separated this because there is a slight difference between Blender version 3.3 and 3.4 in this workflow that is worth highlighting. Let's start with some simple graph data. This is a dataset from my PhD. It's a plot of short circuit current density versus voltage for a perovskite solar cell, but the general approach can be applied to any simple 2D or even 3D graph. What we want is to import the data points and create a curve. We'll start with the 3.3 version. Same as for mesh data, we're going to make sure we have Simon Brogie's add-on installed, and once it is, we're going to come to File, Import, Spreadsheet Importer, navigate to where the file is, and select it, and then add in our specific fields, which you can see I've already got here, making sure that they match what is in the file and also making sure that they are case sensitive. Often, if you run into an error, it's just because there's a problem with this specific part. So rename your variables and then again, save as a CSV. From there, we can go ahead and import. What we can see is that our data has been imported, but as a mesh object, not as a curve. And we're going to convert this in geometry nodes. To do that, we'll come to the geometry nodes workspace. With our object selected, we will go ahead, add a new object here, and we're going to start making a few simple transformations. What we need to do is create a very simple curve and then resample the number of points so that we have effectively the number that we have here. To do that to start, we'll go ahead, hit Shift-A, and I'm very simply going to add a curve primitive line. Every line in Blender by default starts with 2 points, and we need a few more. So I'm going to drag out, create a resample curve node, and the count number here is actually going to match the maximum number that I have in the scene, or 141. So very simply to do that, I can drag this out, grab an attribute statistic, and I'm going to plug in right here the index value. From there, I can grab the max number, choose add. I'm going to add 1 because the index is 1 under the value that I need. From there, I can go ahead, plug this into my resample count right here, and I now have a curve object that has 141 points, just like my original mesh data. What I need to do now is very similar to the mesh, set the positions. Unfortunately, I can't do that directly by just choosing set position in this tree, because the data here is not going to transfer from the geometry into the curve. And that is exactly what I need to do. So very simply, I'm going to reconnect my original geometry by holding Alt Shift and left click. Then I'm going to pull out a transfer attribute node, and I'm going to set this to index. From there, under the attribute, I'll drag out to create a named attribute. And just like before with our mesh data, our data should already be imported, so I can grab my VOC. I'm going to repeat this by simply hitting Shift-D to duplicate. And I'll connect all of those up again. You could do this a little bit more straightforwardly, but this is the way that I'm going to do it today. Let's choose JSC, plug this in to the attribute there, and we'll clean this up just a little bit. As it stands right now, we have the data that we want to transfer from our import, and we have our very simple curved line. If we go ahead and visualize the line, so Alt Shift and left click, you can see it is just going straight up at the moment, and it has exactly the right number of control points that I wanted, 141. We're going to go ahead, drag out, and use a set position. We'll connect this. And again, we're going to reach for the position here, drag out to create a combine XYZ. And if I were using something that had 3 axes, then I would also have to do this for the third or the Z. But in this case, I can very simply just pull my VOC into the X and my JSC into the Y. And you can see this is actually my curve. So if I go ahead, pull this up, this is the curve data. Before we go any further, I want to address the key difference between 3.3 and 3.4. In Blender version 3.4, this is our node tree, and many of the elements are going to look exactly the same. The key distinction here is that version 3.4 removed the transfer attribute node and split it up into other options. In this case, what we want is the sample index node. So you have to plug in the index value here, and then the named attribute. Otherwise, you pass this parameter to the same combine XYZ, and the rest of the setup, the curve, the attribute statistic, all of the set position is still the same. That's the only difference, and so for now we're going to switch back to 3.3. Now that we have our curve, or graph, we can make some slight adjustments. For instance, my JV data goes from a maximum JSC value of 57 all the way down to about -21. Blender is going to express this as meters, and so you can see this graph looks very stretched. I can start to correct this using a transform geometry, which I will effectively use to shrink the y-axis the same as you would by setting the parameters in sort of any graphing software. We're going to go grab a transform geometry, insert that right here, and very simply, I'm just going to bring the y scale down to, let's say, 0.1 to start. Zooming in, you can see this is almost what I would anticipate. I'm actually going to go a little bit smaller. This is something that I might expect to see in a regular standard JV curve in a publication or just in standard data processing. So this is a very nice way to just scale your graphs appropriately. Now that my curve is looking a little bit more reasonable, I want to show some curve-specific tools that I can use for animation and shading. We'll start by adding a curve to mesh node with a curve circle just to give our trace a little bit more presence. So we'll move the group input over, drag out and create a curve to mesh. Use a curve circle for the profile. And I'm going to bring this radius down preemptively and connect this. Now that our curve is a little bit more obvious in the scene, I'm going to go ahead, grab the curve to mesh nodes and move them off to the far side. I'd like to do some simple curve-based transformations. We'll start by pulling from the transform and selecting a trim curve node. We'll connect this up into the curve to mesh. And you can see that I can now effectively use this to draw my curve from either one end or the other. I can also chain these nodes in succession to limit which part of the data I want to work with. So we'll go ahead, duplicate this, connect it in, and now I can draw just within the range defined by the first node. So let's say 0.5 there, and we can go from here to there, or from the end to the beginning, either way. I'm going to use this as the basic setup for some simple shading effects. We'll go ahead and from the trim curve, we're going to grab the node and we'll add in a store named attribute. I'll connect this into my curved mesh, and we're going to go ahead and give this a name of trim factor. For the value, I'm going to grab this socket here, and I'll create a spline parameter node set to factor. Effectively, what this is doing is giving a value from 0 to 1 on either end of the curve. And we're going to use this in shader nodes to achieve some interesting effects. To make sure that we can do that, we'll simply pull out to the side here, and we're going to add a set material node. We'll come to our object material section, and we'll add a new object, which we're just going to call graph material. I'm going to make sure in Eevee that we have bloom enabled, and we're going to select our graph material before moving over to shader nodes. In the shader workspace, I'm going to start by making sure that I'm working on the graph material, the one that I chose in geometry nodes. Once I know that's true, I'm going to go ahead and check on the variables that I have. Specifically, I want to work with the trim factor, and so I am going to use that to control the emission. I'll set an emission color of, let's say, a kind of light blue, and we'll bring the strength up to about 10. What I would like is for certain regions to be brighter, but I could also use this to change aspects of the color or any other material property. In this specific example, I'm going to go ahead, add in an attribute, make sure that this is named appropriately, so trim factor, making sure again, caps and spaces have to match up here, and I'm going to pull the factor output into a compare node. Knowing that my trim factor goes from 0 to 1, I'm going to restrict the epsilon range to just about 0.1 to start. And the 0.5 value should put this right around here. So if I go ahead and use Node Wrangler with Control, Shift, and left click, you can see there's my nice little range right there. I'm going to restrict this epsilon a little bit further. And now I can go ahead and drag this out, create a multiply, and I'll multiply this by 10. So that wherever this is white, it's now going to multiply up to 10, and I can use that to control the emission strength. So now I have this nice little blue part that I can slide along with the value, and I can expand using the compare. And of course, I don't have to use just compare. I could also use something like less than. So any point where it's less than or greater than, I could use this to fill in the graph. So with these tools, you can now directly import CSV data into Blender to use with geometry nodes. This has a huge range of potential applications for animating and visualizing actual scientific data, and in the future I will put together a larger showcase highlighting some useful examples. If there is a specific type of animation or visualization you'd like to see in that showcase, go ahead and leave it in the comments. And with that, thanks for coming out. A big thank you to my supporters on Patreon, to Brady and Arendelle, who helped give me the nudge to get going on it again, to Simon Brogy for creating the add-on, and to George, who pointed it out to me. I had previously started coding this myself using pandas, so this significantly accelerated and simplified the process. When George pointed me towards this add-on, he'd actually used it to create a more straightforward data import for the periodic table I created, and I will likely show that in a future video. If you found this useful, consider subscribing, sharing this with your friends and colleagues, or sharing your data visualization creations with me on Twitter @CGFigures. Until next time, you have yourselves a great old day.